Over 125,000 Americans die annually from not taking their medication properly. This includes forgetting to take medication, consuming the incorrect amount, or taking it in the wrong manner. To put it in perspective, about 50% of all prescriptions filled are taken incorrectly. To prevent this avoidable problem from affecting individuals with disabilities in the workplace, our team developed an idea for an innovation that could automatically dispense the proper amount of medication to users. Our goal was complete elimination of any possible errors.
Since this innovation is geared towards people with disabilities, we had to ensure that it was extremely intuitive and easy to use. To maximize efficiency in the workplace, the innovation had to be easily maintainable and self-sufficient. As a result, the design is such that a manager can load the device with tablets, configure the medication schedule through an Android application, and not have to do anything else until the medication needs to be refilled.
There are a few pill dispensers out there in the market, but they're far too expensive for the average consumer, many in the $600 plus range. The materials in our device only cost about $90 in comparison. What's more is that the devices available on the market don't have too many useful features. They're mostly, at best, storage devices to separate the pills. They don't remind patients to take their pills, which is the root cause of the problem that we are dealing with. In addition, they're not autonomous in any way, and they don't provide clear instructions that make the user experience better. Our pill dispenser, on the contrary, has all of those features and then some.
One of the most important and novel components of our project is the 3D printed cone, which isolates a pill to prevent overdosing. Our goal was to separate one pill from a group of several identical pills, so we found that a textured cone to be the best method of doing so. The way it works is this. When a user flips the device, all of the pills will fall from the pill container into the cone. When the device is flipped again into the upright position, only one pill remains stuck due to the shape of the cone. From there, we can rotate the cone using a servo motor and apply force to it to remove the pill.
We took a modular approach to constructing the frame of the actual device. Since we wanted to contain up to 3 different medications, we created 3 rectangular frames, each of which was its own subsystem. The subsystem consists of a servo motor, cone, wooden dowels, and a pill container. After we mounted the frames and added the top and bottom plates, we had to mount the Arduino, breadboard, and other electronics including the LCD display, tilt sensor, and Bluetooth module. The tilt sensor detects when the user tilts the device and the pill has fallen into the cone. The LCD display makes our project interactive and intuitive. It provides instructions for when the patient is supposed to tilt the device to make the process as easy as possible in only 2 simple flips. Finally, the Bluetooth module communicates with a companion Android application, another core component of the pill dispenser.
The Android application allows caregivers, managers, and employers to program a medication schedule for up to 3 different tablet medications at a time. At the correct time, a Bluetooth signal is automatically sent to the pill dispenser from the application to tell it which medication to dispense. The reason the Android application is so critical to our project is that it makes the device self-sufficient and provides a digital interface for caretakers and managers to work with, differentiating it from every other product in the market.
Here's a demonstration of the pill dispenser being used. For the purpose of simplicity, we are only demonstrating one type of pill being dispensed, although the process works and is similar for all 3. So we have also removed the top plate and our casing to show how exactly the novel dispensing process functions and which electronics we have used in our design. We start by setting a medication schedule on the Android app. In the app, each day of the week can be selected or deselected, and a time can be chosen for when the pill is given. We then save the changes.
The user approaches the device and sees a message on the screen to flip the device. After flipping the device, all pills fall into the cone, but only one gets stuck. Then, the electronic display again tells the user to flip the device back to its upright position. The cone rotates, and the motor vibrates against the cone and knocks the medication out of the device through the bottle. The electronic display then confirms that the medication has been dispensed. The cone returns to its original position, and the device remains dormant until the next time a signal is sent to dispense another pill.
Preliminary testing of the prototype involved ensuring that our cone would indeed capture exactly one pill at a time, as failure to do so could result in overdose or not taking enough of the medication. In our first run of tests, the cone only caught the pill 68% of the time. After retexturing, the second run yielded a 100% success rate.
The other major component of our testing was with the hardware components. We spent time connecting the Bluetooth module with our Android application to ensure a seamless signal transfer. We also spent time debugging our LCD display so that a new instruction would only be displayed once the tilt sensor was activated during the flip. Our greatest challenge in testing was putting everything together: the companion Android app, the hardware, the motors, and the cone-based dispensing mechanism. This entire process was tested over 50 times with various pills and possible use cases.
The pill dispenser focuses on one major problem and solves it completely: patients who need to take medicine doing so improperly. If a patient takes too much of a medication, the side effects can vary from sleepiness and decreased productivity to major problems with vital signs and even death. The pill dispenser ensures accuracy in the number as well as the type of pill taken to prevent this. Furthermore, the pill dispenser employs mobile technology and automation to make the product as efficient as possible. Employers will not have to be worried about that their employees are not taking their medicine, thus allowing them to focus more on their work. After the initial configuration, they will only have to refill their medication and allow the pill dispenser to take care of the rest. Another major concern that our innovation alleviates is the cost factor. The cost of building our prototype was just over $90, which is highly affordable for just about any employer.
Patients with memory-related disabilities such as Alzheimer's disease, Korsakoff syndrome, and dementia will most directly benefit from this innovation. Instead of running the risk of forgetting to take their medication, they will always receive a text message reminder. In addition, the step-by-step guide given in the electronic display will make sure that patients will be able to follow the instructions and successfully retrieve their medication every single time.